right, we're going to finish up this week looking at another method to solve systems of equations. This method works for 2 variable or 3 variable, but we're going to use it mainly with 3 variable. So one of the downsides of the method that we looked at, which was elimination with substitution, is you have lots of options. Right? When you're starting out a 3 variable problem, right, like this one, we're not actually going to go through and solve it right now. You'd have to first say, okay, what letter am I going to try to eliminate? So you look for a letter that has a 1 in front of it. Well, even with that, we still have options. Okay, the x has a 1 in front of it, so does the z, and so does the x in the third equation. So choosing to eliminate either x or z would be a good choice. So you're going to make that choice. And then, after that, you have to decide, okay, I'm going to eliminate z. Which 2 equations do you want to eliminate it from? Do you want to use 1 and 2? Do you want to use 2 and 3? Or do you want to use 1 and 3? Okay? You have to use 2 out of 3 of the pairs that I just said. Right? So there's lots of choices, and sometimes if you make the wrong choice, you start ending up with a problem that's getting hard to solve because of the fractions or different choices you make. So we're going to look at a method today that eliminates all of the choices. So everybody's pretty much going to solve it exactly the same way. So some people like that better, some people don't like that as much. But I'm going to show you the method. So the method that we're going to use, or transition to using, is called a matrix. Okay, so a matrix is just a way to organize a lot of numbers. Think of a matrix as like a table. It has rows in it, and it has columns. Do any kind of programming on a computer, you'd also call something like this an array, a 2-dimensional array. So the nice thing about a matrix is, 1, it's going to make the amount of information we have to write a lot less. We're not going to be writing any variables when we use a matrix. And 2, it's going to organize everything. Make it very, very organized. So when we are looking at a matrix, the way we describe it is by the number of rows and the number of columns that it has. So if I said to you, we have a matrix that's 2 by 3, I'm telling you how many rows and how many columns. The first number is how many rows in the matrix. Rows are horizontal. Columns is the second number, and columns are vertical. If you have a matrix where the number of rows and the number of columns is exactly the same, that's called a square matrix. If the number of rows and the number of columns are the same. We'll be doing some work with square matrices. We'll see that come up. Each thing that's in the matrix is called an element. A matrix it doesn't just have to be used for storing numbers. It can be used to store all kinds of things. Right? We're just using it to store numbers. But technically, if you wanted to store information, I could store letters in the matrix. I could store names of people. I can put whatever I want in the matrix. But we're specifically going to just use it for numbers. So that's an example of a matrix. A lot of times you will see a matrix written in brackets. Just to save us a little bit of writing in the future, I'm probably not going to use the brackets on the outside. But a lot of times you do see the brackets. So this particular matrix is a 3 by 3 matrix. It has 3 rows, and it has 3 columns. When we name a matrix, a lot of times using a capital English letter is the most common way we name it. So this is matrix A. And if you want to refer to a specific number in the matrix, this is the notation that you use. Right here. So you use the same letter as the name of the matrix. You just use the lowercase version. And you put a little subscript, almost looks like a coordinate. Okay, it's not a coordinate because it doesn't have parentheses. But that coordinate tells you first the row that you want to look at, and the second number is the column. So the element that's in the second row, third column, is a 9. That's how you describe a particular element in a matrix. Okay, so as we go through it, I'm probably going to use things like I'll say row 3, column 2, row 2, column 1, right? Row 1, column 1, things like that. So any question on how you identify where something is in a matrix? So this is a matrix. It's just random numbers. Numbers can repeat in a matrix. In that one, I don't think they do, but it's fine if they do. They can repeat. Numbers could be fractions and decimals as well. So the main advantage of using the matrix, I kind of already said this, is we are not going to write any letters the entire time we solve a problem. And letters are half of what we had to write. So it is going to save some writing. All that we're going to write down is the numbers in front of the letters, the coefficients. So then if we get rid of all the letters, how do we know, if we look at something like this, how do we know what all these numbers were originally? Well, each column is going to represent a variable, and it's in alphabetical order. These numbers are going to be what was in front of the x variable. The second column will be the numbers that were in front of the y variable. And the third column will always be the numbers in front of the z variable. So each column will represent the numbers that were in front of a particular letter. So when we're trying to use a matrix, it's important that we look at our equation and make sure that everything is lined up. The x's need to be in the first column, y's in the second, z's in the third. If they give you an equation that's not set up like that, you need to fix, you might have to reorder it so it is like that. Okay, that's the first step. So that matrix that we're going to write down, all the numbers that were in front of the letters in, that is called the coefficient matrix. Because the coefficients are all the numbers that were in front of the letters, and we're writing them in rows and columns. Now, if all we do is write down the numbers that were in front of the letters, we're losing something. We would be writing down all the numbers that you see right here. And if you don't see a number in front, it's always a 1. But if that's all we write down, what if we lost? Yeah?
The number on the other side of the equation.
Right, we've lost the right-hand side. So we need those numbers too, because they were part of the original problem. Yep?
What happens if one of the letters is squared?
No, you won't have anything squared. No, you're only going to have all to the first power. The letters will always be to the first power. So we need to not only write down the coefficients of the letters, but we're going to add on, or with a matrix we call it augment. Okay, we're going to add on another column, and that column is going to represent all the numbers that were on the other side. Okay, and I'll show you how how we do that. So just as a quick example with two variables, if you had something like this, and you wanted to write that as a matrix, you start with all the numbers in front of the letters. 2, 1, -8, and 4. And then we're going to add on a column on the right-hand side for these values. 3, 12. So we remember that the 3 and the 12 were on the right-hand side. We put in that vertical line. That vertical line represents your equal sign. So these are the x's. These are the y's. That's your equal sign. And those are the constants. So that's how you would transfer that information into a matrix. Any question how I did that?
How does this help us?
What's that?
I said, how does this help us?
Well, we haven't learned how to use the matrix yet. So we got to learn the process of what we need to do with this once it's written down. So now I'm going to show you what you do. So first of all, we can see right away it's going to be less writing. You're not going to have to write an x, and we're going to do it for 3 equations. So you're not going to have to write 3 x's, 3 y's, or 3 z's. Those are all going to be left off. So there's 9 letters right away that you don't even have to write. And as we solve the problem, you would have to keep rewriting those letters every single step. So it's probably going to save you from writing 20 to 30 letters over and over. All right, so what's the goal? Once we have a matrix, what are we going to try to do with it? The goal is to get something that looks like this. We're mostly going to be working with matrices that are 3 by 3. So we'll have three numbers there, x, y, z, x, y, z, x, y, z. And those numbers on the other side are going to represent your constants. When we're done, the goal is to get something that looks like this. Where I didn't fill anything in, I just put those 6 dots. I don't care what those are. I'm not going to pay attention to those 6 spots at all. The only 6 spots that I'm going to pay attention to are the ones that I just kind of circled in blue. I need those 6 spots to turn into these values. 1s on what we call the diagonal, and 0s everywhere underneath. The reason we want 0s is because everywhere that you get a 0, it means you just got rid of a letter. And that's always the goal. Eventually, we want an equation where we have gotten rid of 2 out of 3 of the letters, and there's only 1 letter left. If we can get down to an equation with a single letter, then we can solve that equation. And then once we know that answer, we can substitute it back in and get all the other answers. So the end of this problem is very similar to what we did yesterday. Okay, you're going to eventually get one answer by itself, then plug that back in to get your other answer, and then plug both of those back in to get your third answer. But the process of how we get down to that first equation with only 1 letter, that's what's going to be different, and I'm going to show you how we do this. Anytime that you have a matrix that has this pattern to it, it's called row echelon form. Row echelon form, just a fancy term that means 1s on the diagonal and 0s everywhere underneath. But how do you get to that point? You can't just erase the numbers and just make them 1s and 0s. There's rules you have to follow to make that happen. Right? And most of the rules we already know. So I'm going to show you what the rules are. So in order to get a matrix in row echelon form, that's what I just showed on the other page, there are 3 things you're allowed to do, 3 operations. You're allowed to take any 2 rows in the matrix and swap them. That would be like having a system of equations and just changing the order you put the equations in. That doesn't change anything. It doesn't mess up your answer. All right, so you're allowed to take 2 rows and swap them. You're allowed to multiply a row by a number that's not 0. We did this a lot when we did elimination. Okay, sometimes when we wanted to try to get a letter to eliminate, we had to multiply by a constant first. Right, so you can multiply a row by a constant. And the third thing you're allowed to do is add 2 rows together. And that's another thing that we did when we did elimination. A lot of times we'd multiply a row by something first, and then we would add the 2 rows together. And that's what would cancel out a variable. So what we're doing today, it's really what we did yesterday. It's elimination. But it's elimination in a very structured way where you have no choices. You always follow the same steps every time. So there won't be any question like, well, should I try to get X to eliminate, or should I do Z first? No, we're going to always follow the same steps. All right. So that's kind of that's the background, and now we're just going to try a few problems with the matrix. Okay, so does everybody have the 3 things that you're allowed to do? So things you can't do, anything that's not in that list. Could you swap columns? No. You cannot swap 2 columns. You can swap rows, but no, we always want the X's in the first column, Y's in the second, and Z's in the third. Can you divide through by a number? No, we're not going to think of doing any division in these kinds of problems. Everything is going to be multiplied. So if you really want to divide something by 2, then think of it as multiplying it by a half. Okay, that's how we have to think of it. So let's look at this problem. We're not doing it again. I skipped doing it the first time. We're just doing it for the first time right now. So off to the side, let me make a kind of a diagram of the order you have to do things in. There's 6 values that we want to try to get in those 6 spots. Actually, I'll just label this one. The first thing you want to do is that. First thing is you want to get a 1 all the way in the upper left. You have to do that first. Second thing you want to do is get a 0 in row 2, column 1. And the third thing that you want to do is get a 0 in row 3, column 1. That's the first 3 things you have to do. The fourth thing we're going to do is get a 1 right there. The fifth thing that we'll do is get a 0 right where it's pointing. And the last thing that we'll do is get a 1 in that spot. That's the order we have to follow. If you don't follow that order, then what's going to happen is you might get a number that you want in a certain spot, but then in the next step, you're going to mess it up. If you follow this order, once you get the numbers in the spots that I've labeled, you will never mess them up in the next step. They will stay there for the entire problem. So that's why we have to do it in that order. So 1, 2, 3, 4, 5, 6. Just like that. So we basically work a column at a time, starting with the left column, and then work our way to the right. That's how we do it. All right. So first thing I'm going to do is I like to label each equation with a circled number. So anytime that you see me write a number today that is circled, that represents an equation. Okay. So what is the very first thing that we want to try to do? Yeah?
I want to get one of the x's to the
Okay, so we want to get a 1. And where do we want to get a 1 in our matrix? Top left, row 1, column 1. Is there any way that I could get a 1 in the top left by doing one of these three things?
swap 1 and 2.
Yeah, we're going to swap rows 1 and 2. So as I write down my matrix, I'm going to do the swap right away. So we're going to write down 1, -2, -3, 0. I'm putting row 2 at the top. And now I'm going to swap row 1 and put it in the middle. 0, 2, 1, -8. And row 3 is just going to stay right where it is. -1, 1, 2, 3. Always make sure you copy down your numbers correct. I think everything looks good there. All right, so we actually just had two things happen. We got a 1 in the upper left, row 1, column 1. And what else just happened automatically? We got a 0 in row 2, column 1. So now we're already at our third step. We need to get a 0 in that spot. And the only way that we can do it is use what's above it. Does anybody see what I could do with row 1 and row 3 that would turn this into a 0? Yeah, just add them together. So we're going to add row 1 and row 3 together. And this is how you write it down. Take row 1, add it to row 3, and now you have to tell me where are we going to put the answer. That's going to replace what's currently in the third row. So we're going to add row 1 and row 3 together, and we're going to put the answer in the third row. Nothing's happening to rows 1 and 2. They're staying exactly the same.
If it's 1 plus 3, how does it equal 3?
Remember, these aren't numbers. These represent rows. These represent equation 1 plus equation 3, and we're going to put the answer where equation 3 is. And then row 2, we're not replacing anything there. And now let's go through what we have to do. Add equation 1 to equation 3 and put that answer where equation 3 was. What do we get if we add 1 plus -1? 0. What do we get if we add -2 and +1? What is it? Yeah, -1. And then what do we get if we add -3 and +2? Yeah,
-1 again.
-1 again. And what do we get if we add 0 and 3? 3. So that's our first step. All right, so we did our first step, and we've got a 1 in the upper left, 0 in second row, first column, and a 0 in the third row, first column. Any questions how we got this last row? I'll always write down the calculation that we did to get it right before we put down the matrix. Okay, what's the next thing we have to do? We have to get a what? Where? Yep. Right, we have to get a 1 in the middle. So is there anything that we could multiply row 2 by that would create a 1 in the middle? What is it? A half. Yep. So we could multiply by a half. That's generally how you get a 1 in the middle. You multiply by, it won't always be a half, but it's multiplying by something. So we're going to take row 2. Remember, that's not the number 2, that's equation 2. We're going to multiply it by a half. And we're going to replace what's currently in equation 2. Okay. What's going to happen to equation 1? Stays the same. What's going to happen to equation 3? Stays the same. I like to copy down everything that stays the same first, and then I'll write down what's changing. So we've got 1, -2, -3. We've got 0, -1, -1, 3. And now we need to take half of everything that's in row 2. Well, what's half of 0? 0. What's half of 2? 1. Half of 1? Half. And half of 8. -8, sorry. Negative. Okay. So now we've got 4 out of 6 steps done. We've got the first column good. Second column, the 1 is good. What's the next thing that we have to do? Get a 0 where?
The bottom middle.
Bottom in the middle, yeah. We got to get a 0 right here. Is there any way that we could do that? And you can only use the row immediately above it. You can't go back to the first row anymore, because if you try to do something with the first row, you're going to mess up this 0. So we only want to use the row immediately above it.
Yeah.
Yeah, just add them together. We don't even have to multiply by anything. Take row 2. We're going to add it to row 3. And that's going to replace what's currently row 3. Yep, so that's what we're going to do. What's going to happen to row 1? Stays the same. What's going to happen to row 2? Stays the same. Rows 1 and 2 are done for the rest of this problem. There is nothing else we need to fix. Okay? So 1, -2, -3, 0. Okay. So 1, -2, -3, 0. 0, 1, 0.5, -4. And now let's do what it says here. Add row 2 to row 3. What's 0 plus 0? That's why we used row 2, because it already had a 0 here, so adding it to here would never mess up that 0 again. Okay. Next one. What's 1 plus -1? 0. What's 0.5 plus -1? -0.5. And what's -4 plus 3? -1. Okay. So now let's translate this last row. We're done with the matrix now. I know we don't have a 1 in the lower right yet, but it's okay. You'll see what happens. I want to translate that row back to an equation. Can somebody tell me what this equation means if you put all the letters back in it? Yep.
Be 0x.
0x
Plus 0y.
plus 0y
Minus 0.5z.
minus 0.5z
Equals -1.
equals -1. We have eliminated the x and the y, and now we're down to just -0.5z equals -1. And how would you get the z by itself there? Yep. And what would you divide by? -0.5. So that's gone. Negative divided by a negative, that's gone. And what's 1 divided by 0.5? 2. Yeah. So we get z equals 2.
So it wouldn't matter to find that last one, because even if we did, it would get the same answer.
Yeah, we basically did, because what number is in front of z? 1. So we did get a 1 right here.
Oh, okay.
We just did it right here. There's my 1.
Yeah.
1z equals 2.
Okay. Is it always going to be like that, or sometimes do you have to find that last one?
No, once you get to the point where you have two zeros right here, then you can write it back as an equation. And then when you divide each side by whatever number is in front of z, it's always going to turn this into a 1.
Okay.
So that's your 1 right there. And 2 is the number that's on the other side. All right, so now let's take the middle row and turn that back into an equation. What does the middle row say if you put the letters back in that one?
0x plus y plus 45z.
0x plus y plus 0.5z equals -4. The x is gone. The y, we don't, right? The y, we don't know that yet, so I'm just going to leave that as y. But z, we know. Hey, you can come in. Yeah. When we plug in the 2 for z, what's 0.5 times 2? 1. Do you need me to sign something? Yeah, can you just come back in like 25 minutes? I'll be all done. Yeah.
Would it be better if I came back at like a greater like 11 and 10?
Anytime between 10 and 10:40,
Okay.
or between 12 and 12:30.
Are you sure that?
I am not after today. Well, I will be till 2. Well, I'll be here till 2:40, but you could actually come period 9. That would be okay too.
Okay.
Yeah. Sorry, what's 0.5 times 2? 1. And how would you get y by itself?
Subtract.
Subtract 1. So we get y equals -5. All right, so this gave us z. This gave us y. What's the last thing we need? X. So for x, we can just go back to the original equation at the top. 1x minus 2y minus 3z equals 0. Okay. X, we don't know. Minus, let's put in 2 times y. Y is -5. What's -2 times -5? Yes, that's a +10. Z is 2. What's -3 times 2? -6. And that's equal to 0. Okay, what's 10 minus 6? 4. And the last step to get the x by itself, subtract 4. Okay, so we get x equals -4. And that's how we solve for x. So the very end of the problem is the same thing we did yesterday. You get one number and you plug them back in to get the other 2. It's just the difference is, instead of having all the choices we had, this is how we did all our work today. We used a matrix, and those were the steps that it took. Okay, so it takes a little bit of practice to get used to the matrix, but once you do, it is a lot less writing, because I don't have to write down x's, y's, and z's here, here, or here. So that just saved me 27 letters I would have had to write down, and 9 equal signs. It's a lot quicker to just go like that than have to write 9 different times. So it just saves a little time. Any question on that one?
Are you going to have 10 of those on this one?
10 of them? No, I don't think there's 10 of them. Like on the review tomorrow, I want to say there was only 5 questions maybe, or 6. But yeah, I think the review a couple nights ago, that was like 16 or 17 questions. So yeah, we have a lot less number of questions. Yeah, and some of them are not a matrix. It's just asking like, how would you get a 0 in this spot? And you just have to say, I would add row 1 to row 3 together, and they don't even want you to do it. You're just explaining what you would do. All right, let's try this one. what's the first step that we always do when we are writing it as a matrix? We have to get what number in what spot? 1 in the top left. Do we have a 1 in the top left? Yeah, so then we don't need to even do that step where we had to swap at the beginning. We're just going to add them. We're just going to copy it down without all the letters. So 1, 1, 1, 6. 1, negative 1, 5, 16. 3, 1, 1, 16. Even just writing them down, it's a lot faster. Yeah, I'm going to put the line in too. Okay, always double check you copied it right, because unfortunately you make one mistake copying it and then everything is messed up. All right, what is the next thing we want? So I'm looking for what number do I need to get and where do I need to get it?
0 in the second column. First column, second row.
0 right here, so we're going to try to do that. And this is the only step where we do something else at the same time. Where else do I want a 0? Where? The one below it. So we are going to do both of those in the same step. All right. Let's look for the simplest thing we could do. We've got to use row 1. Can we add row 1 and row 2 together, and it will create a 0 when you add those two numbers? No. So we can't just add them together this time. That means you need to multiply row 1 by a number first. What could you multiply row 1 by? Yes. No, you can't multiply by 0. So you can only multiply by a number that is not 0. If you multiply by 0, you basically wipe out everything. Then you don't have anything left. So what could we multiply this top row by?
-1.
Yep, we're going to multiply it by -1. And this is how we write it. So row 1 times -1. And we're going to add that to what row? Row 2. So we're going to multiply row 1 by -1. We're going to add it to row 2. And that's going to replace what's currently in row 2. Any question on that step?
Why wouldn't you times -1 by the second row?
Because we want to, in this step, we want to multiply always the first row by something. So yeah, in the first step, you're trying to get zeros here and here. Multiply the top row by something so that you can add it to the second to make a 0. Now, we're going to do the same thing here. If we add row 1 and row 3, will that make a 0? No, it would make a 4. So we've got to multiply row 1 by something so that when we add it to row 2, we get a 0.
-3.
We're going to multiply it by -3. Yep. So we're going to do -3 times the first row. Then we're going to add it. Oops. We're going to add it to the third row, and that's going to replace what's in the third row. This is the only step where we are going to do two things at the same time. We're going to get a 0 here and here. What's happening to the first row? It's staying the same. 1, 1, 1, 6. Once you get a 1 in this spot right here, you are done with row 1 the rest of the problem. You cannot ever change it again. All right, so 1, 1, 1, 6, we're going to copy that down a bunch of times. All right, now let's do what this says. Multiply row 1 by -1 and add it to row 2. So let's start with row 1. What do you get if you multiply this by -1? -1 plus 1. 0. Do it again. What's this times -1? -1 plus -1. It's -2. What's this times -1? -1 plus 5. 4. And don't forget about the right side. What's 6 times -1? -6 plus 16. 10. Okay, so we're done with that step. We got a 0 where we wanted it. Now we're going to get a 0 in the lower left. So multiply everything in row 1 by -3 and add it to row 3. What's 1 times -3 plus 3? 0. Do it again. What's 1 times -3 plus 1? -2. Okay, what's 1 times -3? -3 plus 1? It's -2 again. And the last one, what's 6 times -3? -18 plus 16. -2. Okay. So first column is good, 1, 0, 0. What do we have to do next? Get a 1 in the middle. And the way you do that is you always multiply the middle row by a number. Is there anything I could multiply row 2 by to get a 1 in the middle? -1/2. Yep. So take row 2, multiply it by -1/2, and that's going to replace what's currently in row 2. Yep. What's going to happen to row 1? Stays the same. What's going to happen to row 3? Stays the same. And now let's do what that step says. Multiply everything in row 2 by -1/2. What's 0 times -1/2? 0. What's -2 times -1/2? 1. What's 4 times -1/2? -2. And what's 10 times -1/2? -5. Okay. Rows 1 and 2 are now completely done. You've got the 1 in the upper left, and in row 2, it starts with 0 and 1. So there's only one thing left we have to fix in row 3. What's the last thing we need in row 3?
0.
A 0 where?
On the bottom middle.
Right in the middle. Okay. Can you just add row 2 and row 3 together, and that'll make a 0? No. Then that means we've got to multiply row 2 by a number first. So row 2 times something, but we got to figure out what that number is. 2. Yeah. We're going to double everything in row 2. Add it to row 3, and that's going to replace what's currently in row 3. Yep. So what's happening to rows 1 and 2? They're staying the same. 1, 1, 1, 6, 0, 1, -2, -5. Okay, so double everything in row 2 and add it to row 3. Okay. What do you get if you double 0? 0, and then add it to 0. How about if you double 1? 2, and add it to -2? 0. What if you double -2? -4 plus -2? -6, and double -5, and plus -2? -12. Okay, so now we're done with the matrix. We've got everything that we need. What does this last row tell me? Right, you've created an equation that doesn't have an x, doesn't have a y, just has a z. So now you can solve for z. And what would z equal when you solve there? 2. Okay, so there's our first answer. Now we're going to go back and find y. And which row would I use to do that? Middle. What does that middle row tell me if you change everything back to letters? So I'm going to write it as y minus 2z equals -5. And now fill in what have you got for z. So y minus, what's -2 times 2? -4. then when we solve for y, what would we get? Negative 1. Yeah.
What a no solution look like?
We're probably not going to look at a special case with these kinds of problems. But a no solution would basically end up with like a row of zeros and then a number like that. It's impossible to multiply 0x plus 0y plus 0z and have it equal 5. Because you can't multiply a bunch of things by 0, add them up, and get 5. But that's what a no solution is. But that won't happen. All right, so the last thing we have to find is x. Okay, so we got z, we got y. Which row do we use to get x? Top. And the top row, oops, I don't want to erase it, but the top row says x plus y plus z equals 6. Okay, fill in everything you have. Take your y, take your z, and then the only letter we won't know is x, and we're going to solve for it. So x, y is negative 1, z is 2. What's negative 1 plus 2 give me? 1. Which means x would equal 5. Notice the numbers are coming out nice. It's not that every problem has to, but the ones I give you will. So if you're solving a 3-variable system and you start getting into problems that's like your answers are like 2.41986, you probably made a mistake because I'm going to give you ones that come out nicer than that. But that's our steps. So everything here is what we did with the matrix. A lot of times the matrix ends up being about 3 steps like that. Sometimes 4, but 3 is pretty common. And then once you do your matrix steps, you'll know your first letter, and then you plug it back in to get your last 2. Okay. Any question on that one? They all work pretty much exactly like that. I have a lot of examples, but I'm not going to do them all. Let's look at this one. This one I don't want to necessarily go through and solve it, but I do want to at least set it up. Okay, because if we can set it up, solving it would be just like the last 2 problems. So first sentence says the sum of 3 numbers is 4. How many variables do you think you're going to need in this problem? 3. You have 3 numbers. What would be 3 good letters to use? Yeah. So we'll say that x is my first number, y is the second number, and z is the third number. How could you translate just that part into an equation?
X plus y plus z.
Yeah, there's your first equation. X plus y plus z, the sum of all 3 numbers, means equals, and then what is on the other side? 4. Okay, so there's your first equation. Okay, the second equation is going to be this one. The first minus the second plus 5 times the third. Okay? How would you write the first minus the second?
X minus
So there's the first minus the second,
plus 5
plus 5 times the third. That's 5z
equals negative.
equals negative 24. Yep. And the last equation is the third plus 5 times the first plus the second is 24. So let's just go right in order. What's the third? Z. Bless you. So z plus 5 times the first plus 5 times the first. Yep. Plus the second. plus y is 24. Okay, so there's your equations. There's just one problem with the last one. It's not in the right order. It's not that we did anything wrong, it's just the way we wrote it down. We did it in the order they wrote it. So we have to fix it, so what letter is first? Right, so we would want to rewrite this as 5x,
Plus y.
then put the plus y, then put the plus z. So there's your three equations, and you already have a 1 in the upper left, so you're not going to have to do that thing where you swap. You're ready to solve, just like we did the first two. Okay, so you probably will see a question very similar to that, where I give you 3 letters, and you've got to find the 3 numbers. Any question on that one? All right, so if you see a problem in the homework tonight that has 2 variables, and even though if it says to use a matrix, you can go back and do substitution or elimination. You can use the method we learned yesterday. But if you do see a problem that has the 3 variables, I want you to try the method that we learned today for 3 variables. Okay, but 2, you can go back and do the other way. Now, I'm not going to go through it all, but this one is missing a letter. What letter is it missing? So how many y's do you really have in the first one? 0 y. So I would think of it like this right away. Oops. It's x and z, I just copied down, and I didn't have a y, so I filled in a 0. That's going to make arithmetic a lot easier. Anywhere that you already have a 0, that gives you kind of an advantage when you start the problem.
Just swap the bottom and top.
Yeah, we could swap rows if you want. Remember, we do have to get a 1 in the upper left first. So
Which is the bottom.
let's say, even if you had a 0 right here already, unfortunately, that 0 is probably going to get messed up because it's a 0 in a spot, but we haven't dealt with all these first yet. So once you deal with these, it could potentially mess up this 0. Right? So zeros in other spots are great, but they're not guaranteed to stay a 0 until you follow the order that I showed you. This one is very similar. Notice it's got a couple zeros in it. It's got a 0z here, and it has a 0x. This would be a good one because you already have an x and it's in the column it's supposed to be in. That 0 will not get messed up. That one's fine because it's in the first column. All right, so actually somebody asked me this. What happens if you have a no solution or infinite solutions? Both of those can happen, but it's not something that we're going to look at with matrices. So all the ones that we do are going to solve like I showed you in class. So I think like 17 and 18, those are I think those might be 2 variable systems. 1 through 6 is just asking for like a step, saying like, okay, what would you do to make a 0? Add row 1 to row 2. But you don't actually have to do the step. You just have to say what you would do. And then I want to say maybe 21, 24, and 31. Those are 1-word problem, and then a couple 3 variables. But they are not all 3 variable problems. Okay, so we'll look at that first thing tomorrow, and then whatever time we have left, you'll have time to do the review worksheet for the test.